Here in this video we will try to solve the Leetcode problem house robber. Here it's a type of dynamic programming. So here we are given a list of numbers and we need to find the maximum amount of money that we can rob. And here one rule that we cannot rob two adjacent houses. So here each element in our array stands for the house's value. So it's here like written that it will automatically contact the police if two adjacent houses were broken into one the same night on the same night. So let's take at the let's take a look at the examples. Here we are given the list of numbers 1 2 3 1, and here our output is 4 because we can like rob this 1 and this 3. And here if we like rob this 1, we cannot rob this 2. So this means like if we like rob this 2, like we cannot take this 2 and 3. So that's why our output is maximum is 4. So let's take a look at this example. Here our result is 12 because we can rob this house. We skip this and we go for this one, so it's 11 already. We rob this house, so it means like we cannot rob this house, so we go for the last one. So our result would be 12. So here as you can see we have one rule. If we rob this one, we skip the next one. And if we don't rob this one, we just go for the next house. If we don't rob, we just go to the next one. Yeah, to the next one. So here we will use like recursion calls. So let me like write the code and explain it while I'm writing the code. So here let me write my like recursion call function. Here we'll have our array and we will have an indices where we are right now. So if our indices so let's write our base case. So if our indices is more than our ham's array's length or equal, here we should just return all 0. So it's our base case. So here we will have two paths. We can rob and skip the next one as it's written here. So let's write it to rob. So we take this current house's value, we take this one and add the solve. We call our function recursively and go to the second next one like this. If we decide to not rob, let's say not rob, we just go for the next one, hams I plus 1. At the end we will take the maximum of these two numbers. As I told here, we need to find the maximum amount, rob and not rob. So let's call our function here nums with indices 0. So let's check if this will work at our examples. Here I forgot the max function. Wait a little bit. So let's check. Yeah, it works for our examples, but here we need to also implement the memoization part. So we don't need to calculate our uh, indexes more than one. So here we'll have our array dp. So let's give it here num.length. We'll check if our current indices is calculated already. If it's null, so this means we have already calculated our like result for this indices. So let's return it, just return it like this. Also here we have to give this dp array as argument, and we need to write it like this. So let's check if this will work. Yeah, let's submit our code and see how it will work. Yeah, good. It passes all the test cases and it works well. So this way is called memoization way, and here we are using the recursion calls. Here our space complexity, as we use stack for the recursion calls, it would look like O of log n for the space, and for the time complexity it would run just once the whole array, so the time complexity would be O of n, where n is our length of our array. It's memoization way, yeah, memoization way. So let me show you also one way. It's called tabulation. Tabulation way. So here we will not use the stack for the recursion. We will not use like recursive calls. We will just use one loop. Also here space complexity is not of log n, because here we use array for this. So here also space complexity is O of n. I were mistaken. So here we will use array at the tabulation way. So nums.length. Our first result would be just these houses. Our first dp result would be just this house, because we can not drop the previous ones, so we'll just take this one, nums.0, and then we're gonna start like looping our array with starting from 1, because we have already answer for the 0 index. So let's it like this. We'll go through our whole array by 1. And then our current result would be the maximum of 2 ways. One way is to drop. We take this value and add the previous one's value as here. So this way is writing this way, but by tabulation. And then we can just take the previous result, I of -1, and then return our dp of nums.length -1. Also here we need to check for the exception array out of index. So we need to check if our I is 1, we just return 0. If not, we have to take this one. So let's run and check if this works. Yep, it works, absolutely works. So let's submit this way and see. Yep. Also here the space complexity is O of n, and the time complexity is also O of n. The space O of n, because we use extra array to store our calculated results. O of n, because we just loop once through the whole array. So I think that's all for this problem. Bye.